All right, today we're doing a refresher on solving quadratics with square roots and the quadratic formula. So first off, we have the square root property. If x squared is equal to k, then x is equal to positive or negative square root of k. Remember, you need that plus or minus. So what that means is to solve a squared equals 49, I undo the square with a square root on both sides. Well, the square root of a squared is just a. The square root of 49 is positive or negative 7. Now you could write this as a equals positive 7 or a equals negative 7 as well, but you do need both answers. For w plus 3 squared equals 8, we have to undo the square first. So I take the square root of both sides. That leaves me with just w plus 3 equals positive or negative square root of 8. We have to fully get the w by itself, so I need to subtract 3 on each side, which leaves me with w equals negative 3 plus or minus the square root of 8. Generally speaking, you'll see the plus or minus square root part at the end. But we're not quite done. We have to simplify the square root of 8. So we have to think of what perfect square goes into 8. Well, 4 is a perfect square, and 4 times 2 makes 8. We can break apart those two square roots to make it the square root of 4 times the square root of 2. The square root of 4 we know is 2, and leave the square root of 2 trapped. So this is all kind of a sidebar. We're going to replace the square root of 8, so negative 3 plus or minus, with 2 square root 2. There is our final answer. For 5n squared minus 7 equals 488, the first thing we need to do is get the squared thing alone. So we're going to add 7 to both sides, making 5n squared equals 495. And then we're going to divide both sides by 5. Making n squared equals 99. Then we undo the square using a square root. So n squared equals positive or negative square root of 99. Well, what perfect square can go into 99? Oops, why am I putting a square there? Just n. Well, I can make it 9 times 11, because I can then split those apart and make it the square root of 9 times the square root of 11. And I know that the square root of 9 is 3, and the square root of 11 stays with that plus or minus in the front. For this next one, again, get the squared thing alone first, so we're going to add 36 to both sides. We get 3x plus 1 squared equals 36. Now to undo the square, we do the square root of both sides, giving me 3x plus 1 equals positive or negative 6, because the square root of 36 is just 6. Now when I get an actual number here instead of something that has a square root, I'm going to need to solve two equations. 3x plus 1 equals positive 6, and 3x plus 1 equals negative 6. It is not enough for me to leave a plus or minus in my final answer. So we're going to solve each of these, so I'll subtract 1 from both sides, giving me 3x equals 5, and then divide by 3, giving me x equals 5/3. And the other one will solve exactly the same way. I'll subtract 1, giving me 3x equals negative 7, and then I'll divide by 3, giving me x equals negative 7/3. There are my two answers. All right, again, our first step needs to be get the squared thing alone. So we're going to add the 16 to both sides. It gives me 1/4 times x plus 1 squared equals 16. Now we need to undo that 1/4. Well, the opposite of multiplying by 1/4 is dividing by 1/4, or multiplying by 4. So we have x plus 1 all squared equals 64. Now I can undo my square with a square root. So x plus 1 equals positive or negative 8, because 8 is the square root of 64. And I subtract 1 from both sides. Well, positive 8 minus 1 is 7, and negative 8 minus 1 is negative 9, so I have my two solutions. And finally, we're going to get the squared thing alone first, so we're going to subtract 127 from both sides. We get x plus 5 squared equals negative 121, and we take the square root of both sides. Now here, I get a square root of a negative, and anytime I square root a negative, I get an imaginary number. So for right now, we're going to go with no real solutions as our final answer until we talk more about imaginary numbers. The other part of today is the quadratic formula. A reminder that the quadratic formula, we have ax squared plus bx plus c equals 0. It has to equal 0. A, b, and c are just those numbers that will be plugged into your equation. The quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, you do have to memorize that. To solve an equation using the quadratic formula, we need the whole thing to equal 0, but we also need it to look like ax squared plus bx plus c equals 0. So first I need to multiply this out. X times x makes x squared. X times 8 makes minus 8x equals 3. And then I need it to equal 0, so I'm going to subtract that 3 off both sides, giving me x squared minus 8x minus 3 equals 0. Now I identify my a, b, and c. My a is the coefficient on my x squared, which is 1. My b is the coefficient on the x, which is negative 8. And my c is the constant, which is negative 3. Do not forget those negatives. So now we plug it into the quadratic formula. Negative b, so negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2a, so a is 1. Now we just simplify. Negative 8 makes positive 8. Negative 8 squared is 64. 4 times 1 times negative 3 makes it a plus 12, all over 2. And then we're going to add those numbers together inside the square root. We get 8 plus or minus the square root of 76 all over 2. Now here's where the simplifying comes in very important. The square root of 76, a perfect square that goes into 76, we can do 4 times 19. And I know the square root of 4 times the square root of 19. Well, the square root of 4 is 2, and the square root of 19 is just stuck. So we're going to replace the square root of 76 with 2 square root 19. And the reason we do that is because now I see that my 8, my 2, and my 2 can all be divided by something. I can divide everything by 2, making it 4 plus or minus 1 square root 19 all over 1. Well, 1 times the square root of 19 is just the square root of 19. And dividing by 1, there's really no point in writing it. So my answer is actually just 4 plus or minus the square root of 19. Notice that when we simplify this fraction, we don't change anything about the square root. It stays the square root of 19. That will always stay that way. So let's try another one. First off, I'm going to identify a, b, and c. Well, my a value will be 9, my b will be negative 12, and my c will be negative 1 because it's already equal to 0. Now I plug it in. X is equal to negative 12 plus or minus the square root of negative 12 squared minus 4 times 9 times negative 1 all over 2 times 9. Well, now I simplify. My double negative on the 12 makes it a plus positive 12. Plus or minus the square root of negative 12 squared is 144. 36 times negative 1 makes plus 36. All over 18. Please be careful that it is all over 18 and you don't leave that 12 out. Then we'll add together inside the square root. We get 12 plus or minus the square root of 180 all over 18. Now we're going to simplify the square root of 180. Perfect squares that go into 180. I'm pretty sure 36 does. 180 divided by 36 is 5, so it's 36 times 5. Split those apart. Square root of 36 times square root of 5 is 6 square root 5. That'll help me with my simplifying because now I have 12 plus or minus 6 square root 5 over 18. And I can divide everything by 6, making it 2 plus or minus 1 square root 5 over 3 as my final answer. All right, for our next one here, we have to get it equal to 0. So the first thing I should do is add the 2. I get x squared minus 4x minus 21 equals 0. Now I can identify that a is 1, b is negative 4, and c is negative 21. I'll plug those into my quadratic formula. Negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 21 all over 2 times 1. Double negative on the 4 makes it a positive 4 plus or minus the square root of 16 plus 84 all over 2. Add that 16 and that 84, we get plus or minus the square root of 100. Well, this problem's special because we know the square root of 100. The square root of 100 is just 10. So I no longer have a square root in my problem. I have to actually figure out each answer. So x is equal to 4 plus 10 over 2, and x is equal to 4 minus 10 all over 2. Well, 4 plus 10 over 2 is going to be 7, and 4 minus 10 over 2 is negative 3. Anytime you get answers that don't have a square root in them, it tells you could have factored originally. So I could have skipped all of this work, or from right here I could have said, oh, well, that factors to x minus 7 times x plus 3. And then look at that, x equals 7, x equals negative 3, much more quickly than quadratic formula. The quadratic formula will always work. Factoring may not. All right, for this next one, we're going to start by getting it equal to 0. So I'm going to subtract 4 off both sides. I get 8x squared plus 16x minus 10 equals 0. We're going to practice with the quadratic formula. I'm not even going to try to factor. A is equal to 8, B is equal to 16, and C is equal to negative 10. So negative 16 plus or minus the square root of 16 squared minus 4 times 8 times negative 10 all over 2 times 8. Simplifying makes it negative 16 plus or minus the square root of, I don't know, 16 squared off the top of my head, 256 plus 320 all over 16. Add those numbers together inside my square root. I get the square root of 576 all over 16. Now, I don't know all my perfect squares right off the top of my head, but I always just try to see if that's a perfect square right away, and it happens to be. The square root of 576 is 24. So I'm not going to have a square root in my answer. My answers are negative 16 plus 24 all over 16, which makes 1/2, and negative 16 minus 24 all over 16, which makes negative 5/2. So there are my two answers. All right, this next one is already equal to 0, so I just dive right in. My A value is 3, B is negative 24, and C is negative 6. So now I dive in negative 24 plus or minus the square root of negative 24 squared minus 4 times 3 times negative 6 all over 2 times 3. For my simplifying, the double negative makes positive 24. Plus or minus the square root of negative 24 squared is 576. Minus 4 times 3 times negative 6 makes it a plus 72. All over 6. Add together inside my square roots. I get 24 plus or minus the square root of 648. All over 6. Now 648 happens to not be a perfect square. So I need to figure out what goes into 648. Well, I'm going to guess and check a little bit. I found out that 36 times 18 goes into 648. And I know the square root of 36, so that's helpful. The square root of 36 is 6, and the square root of 18 is stuck. But now I check again, because 18 can actually be factored or broken down further. I can make 18 into 9 times 2. And because I know the square root of 9, that makes my life a little easier. So I have 6 times 3 times the square root of 2, or 18 square root 2. So that really tells me that whatever 18 squared is went into 648 originally. So we're going to change our 648 into 18 square root 2. And now I can divide everything by 6. Remember that square root is exempt from that. Making it 4 plus or minus 3 square root 2 all over 1. And one final problem for us here. We're going to start by getting it equal to 0. So I'm going to add the 10 to both sides. I get 2x squared minus 7x minus 3 equals 0. My a is 2, b is negative 7, and c is negative 3. Now we plug it in. X is equal to negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 3 all over 2 times 2. Well, double negative makes it a positive 7 plus or minus the square root negative 7 squared is 49. 4 times 2 times 3 will be 24, and it'll be a plus all over 4. Add together those numbers inside the square root, I get 73. And the square root of 73 doesn't simplify, so that is my final answer, 7 plus or minus the square root of 73 all over 4.